Hello and welcome to episode 1 of Let's Code an Indie Game. In this series I'm going to be taking people through the tools and techniques they need to become a one-person development team and make their own games. So we're going to be looking at pixel art, we're going to be looking at chiptunes, and in the first couple of episodes we are going to be looking at code and how you write some code to make your game work. Simple as that. So let's start off by looking at the tools we will be using. So we're going to use the Love2D framework to write our game. It's a nice combination of being simple while at the same time letting you do everything you could want to do for a 2D game. It also runs on Windows, Mac and Ubuntu, as you can see here. So getting it set up is as simple as going to the website love2d.org and having a quick read and installing the version of Love for your platform. So I'm not going to run through that on the video because I'm sure everyone can go away, do that for themselves. The second thing you'll need is a decent text editor. I'm using Atom, which is available for free from atom.io. But if there's another text editor that you prefer, then go ahead and use that one instead, by all means. But if you do want to follow along exactly with what I'm doing, then you will need Atom. Finally, if you want to have a look at any of the code which I'm writing during this episode, it will be available on GitHub afterwards. You can find the link in the description, but if you prefer to go there for yourself, it's github.com/hypnoscope. Right, so let's assume that you've downloaded Love2D, you've installed Atom, and you're ready to create your first game. The first thing you need to do is create a new folder. So let's do that now. I'm using console to do this, but you can of course use whichever method you want, whichever method you're most comfortable with in creating a new directory. So here we have it, episode 1. Let's move into episode 1 and let's open up our text editor. Here we go. We'll just wait for the laptop to finish thinking, and here we go, episode 1, nice and empty. So let's make our first file. Our first file is going to be called main.lua. So Lua is the programming language that you use to talk to the Love2D framework. It's a scripting language, pretty lightweight, borrows some syntax from BASIC and other things from JavaScript. So if you've done any amount of coding, and I'm going to assume people maybe know what code is but don't have much more knowledge than that, then you should be pretty comfortable. So let's start off by just drawing anything, just to prove that this is simple and we can get started. So we'll start off by doing love.draw, and this is inside of our main file, equals function. We won't worry about any arguments for now, and we'll stick an end at the bottom, and that will close our function definition. So inside of the love.draw function is where you define all of the code you want to actually draw to the screen. So let's stick in a love.graphics.rectangle, which will unsurprisingly draw a rectangle. We are going to use the fill mode. We're going to draw it, so X and Y is your positions, we're going to draw it at 0, 0, and let's make it 100 by 100. And before we run the game, let's also set the color. You set the color using RGB or red, green, blue values. So let's go for 200 red, about 40 green, and maybe 200 blue. And this should give us a nice visible pink color. And let's have a look at running the game. So if you are using the command line, and you will need to either use the command line or you can install a package in Atom to do it, but the simplest way is the command line. So if you have a Unix style command line, which I'm using here, then you simply put the path to the love executable, which on my system is in program files love.exe, and then you point it to the directory that your code is installed in. So in this case I'm just going to put dot because I'm already in the episode 1 directory. And if we hit enter, we see that we have our game, and here is our pink rectangle, well it's more of a square, drawn at position 0, 0. So a good thing to notice here is that our coordinate system starts up at 0, 0 here, and as the numbers increase we get further towards the bottom corner down here. Right, let's make things a little more interesting. By the way, if you're using a more Windows style command line, you can do exactly the same thing, just point love to your directory. What I'm going to be doing for most of this episode is I'm going to just be hitting Alt-L inside of Atom because I have a package installed called Love Launcher, which launches the game for you. It's just a bit more convenient. Again, I'll put a link to where you can find installation instructions in the video description, but if not, you can really just Google it or or search inside of Atom and find it for yourself. Right, so we are able to draw a rectangle to the screen. Let's actually move a rectangle around, shall we? So the first thing we're going to do is introduce a couple of variables, x and y, and we will use these to store the x and y position of our rectangle. The next thing we'll do is introduce love.update. So these functions which you define in your main.lua file, this is really your main way of talking to the Love2D framework. So Love has this idea of functions which should exist, and by overwriting them you are able to give the game or give Love some instructions. So update is where you put all of the logic for your game. Draw, unsurprisingly, is where you put all of the graphics and the drawing. Update is more for moving things around, changing any AI code that you've got going on, and looking at this is the more of the logic. Both of these run as in a loop, which means they run over and over again, and they run as fast as the framework can run them, so you get a nice smooth consistent updating of both your graphics and your game logic. So inside of our update function, let's change our x value. So we'll say x equals x plus 1. And when we draw our rectangle down here, we'll use our x and y values instead of just hard coding 0, 0. So let's see what happens if we run the game now. Great! Our square is slowly moving across the screen. Now, if we wait for it to move off the screen completely, there'll be no way of getting it back because we are x at the moment is just going up and up and up. So let's just come in here and we will say if x is greater than, again we can get the width of the screen here using love.graphics. So any code to do with graphics is inside of the love.graphics module. So if x is greater than love.graphics.getWidth, then we stick an end at the end of our if blocks. So in Lua you do ifs, whens and control flow. Generally they're all terminated with an end. If also has a then in it, so we'll say if x is bigger than the width, then we will say x equals 0. And also let's make it a bit faster and let's see what happens now. Cool, so now when our square hits the end of the screen, it will teleport back to the beginning. Excellent. Now you can imagine at this point that we could keep going, but if we wrote all of the code for our game inside of this main function, we would end up with one giant function. It would be hard to read, it would be hard to come back and improve it. So one of the things I really want to focus on in this series is how you write nice maintainable code, because if you're a one-person developer, or even if you're part of a small team, or even a big team, you want your code to be nice and maintainable. You want to be able to look at it, tell what it's doing, you want to know what happens when you change it so you don't break anything else. And an important part of that is how you structure your code. So let's make a new folder, and we're going to call that folder source, or src, which is a pretty common abbreviation for source, and this is where we're going to put most of our source code. It's important that main.lua stays in the episode 1 directory because that's where the Love2D framework will look for the main file, but the rest of our code we can put inside of source. So let's make a new file, or a new folder, sorry, inside of source, and let's call it graphics. And finally, inside of graphics, let's make a new file, and we're going to call this sprite.lua. And let's write some code for drawing a sprite to the screen. So we can draw rectangles, we can draw them in any color we want, but let's actually draw an image which which is being prepared, which we prepared earlier. So the first thing we're going to do inside of our sprite file is do local sprite equals empty, or open bracket, close bracket. And what this means in Lua is it is an empty table. So instead of, in most languages you have this idea of an object or a dictionary for storing data in Lua everything is a table. So that's an empty table, and we're now going to return it. So at the moment we're just returning an empty object from this file, but by building up this empty object we can create a sprite class, which is a template for all the sprites we want to create in our game. But by doing it this way we're not going to expose any of the inner workings of our class to the rest of our code, and that means we can't accidentally break it, because the less things you expose, the less chance you break it later. You want to tidy up after yourself, keep things nice and neat. So on our sprite we are going to add a create function, and we do this by just doing sprite.create equals function end. Now if you notice, because we're returning sprite at the end, this means we can access this function by doing sprite.create in other files. So let's think about the arguments we need to pass to this function in order to create a sprite. We will need the location of the image, so let's call that image path, and we'll need an x value and a y value. And we will probably come back and change this later, but for episode 1 this feels like a pretty good start. So inside of our sprite.create method, let's create an instance. And again, we're going to do a very similar thing. We're going to say local instance equals empty table, and then we're going to return our instance. What this will do is create a new sprite object for every sprite.create which we call, which is what we want, because each sprite needs to be its own object. It needs to look after its own images and its own position. Fantastic. Now let's add our x value into our instance and our y value into our instance, or assign rather than add. So now instance.x, instance.y equals the x and y values we're passing into the function. And also let's think about our image. So the way you load images into love2d is you do a love.graphics again, because it is to do with graphics, and you do new image file name. So we just pass our image path in here, and now the instance of our object has the image loaded into it. When we call create, we will load the image and be able to do things with it. So what else does our sprite need to be able to do? Well, it would be pretty handy if it could draw. So let's create a draw method, and we're going to do this outside of our create function, and we're going to make it local to this file, which means, as I said earlier, people won't be able to come along, or it won't be as easy to break the function later. We don't want to be able to access the draw method from everywhere. We only want to be able to access it from our sprite. And the first argument we're going to pass in is self. That's because we want this to be a method which we call on the instance of our sprite, not on the module itself. Now that may seem a bit confusing. I'm throwing in a lot of terminology, but don't worry, it will become clear as we write more code. The best way of learning code is just to write code, and eventually it will click, it will make sense, and everyone is happy. So for now we're just going to say the first argument, and in fact the only argument we pass into draw, is going to be self. And inside of draw, let's do a love.graphics.draw, and we can use self.image. So now you can see that we are going to grab the image which we assign to the instance of the object down here and use it to draw the object up here. Draw also takes a couple more arguments, but the arguments we care about right now are x and y. So let's go ahead and use self.x and self.y. There we go. And finally we want to make our draw method available on the instance of the object. So we'll do instance.draw equals draw. Fantastic. Now let's use our draw method inside of our main function. So the way we do that is we use require. So we can say local sprite equals require, and we can put the path to our file you always start at the top next to your main.lua file, so because this is the first file the game sees or Love sees when it starts. So in our case, our file is in source.graphics.sprite. There we go. Notice we're using dots, we're not using forward or backward slashes. That's because Love is platform independent and Windows uses one direction, Unix uses another direction. Everyone gets confused, so we're going to use dots. We can all agree to use dots. Right, so we've pulled in our sprite file. Files, when used like this, are actually called modules. So what we've done is we've created our first module. So we've pulled in our sprite module, and we are going to introduce another top-level function here. This one is going to be love.load. So love.load is used by the framework to, unsurprisingly, load things. This isn't load like load the game, this is load as in set up everything that has to happen before you start updating and drawing. So inside of load, first of all, let's create an empty variable to hold our sprite, which we will call adventurer. And then inside of load, we can assign that variable to sprite.create. And now we need to worry about where our image comes from, and to start with we'll just draw it at 0, 0. Actually, let's draw it at x and y, as we have x and y already available for us. It would be a shame not to use them. So I'm going to put all of the images and everything which isn't code inside of a folder called assets. Again, you can put them anywhere you like, but things will go much more neatly if you stick to some kind of order. So let's make a new folder in here called sprites, and I'm actually going to cheat and copy over a sprite I used earlier. So previously I've streamed this episode on Twitch. I'm recording it again for YouTube, hopefully just to get the quality up a bit and to give people a better forum for asking questions. So if you bear with me one moment, I'm just going to copy over a file which we used previously, which is in Twitch assets adventurer.png. Excellent. And we'll move that into assets sprites, or copy. And if we just check inside of assets sprites, yep, adventurer.png. So now in sprite.create we can pass in assets sprites adventurer.png. And finally, in our draw function, let's get rid of set color and rectangle and replace this with adventurer draw. And notice it's very important here that when we call the draw function, we use the colon rather than dot. And what this does is it is the same as writing adventurer.draw adventurer. And this is because we used self as our first argument, so we want the draw function inside of the sprite module to have access to everything on our adventurer. We could write it this way, but it's much neater to write it this way, and it reminds us that the adventurer is an instance of a sprite. It's not the sprite class itself. Cool, let's see what happens when we run the game. We have an adventurer. They are up here in the corner. You'll notice a couple of things straight away. One, our adventurer isn't moving, even though we're updating the x value. That's because we take the x value once when we create the sprite. So if we want to update it, we'll need to go back and change our code. And two, our adventurer is very tiny at the moment. So let's scale our adventurer up first of all. So inside of our sprite class, we can add a few more arguments here. So one of the nice things, or sometimes confusing, sometimes nice things about Lua is if you don't provide arguments have to be in the right order, but if you reach the number of arguments you want to use, you don't have to provide the extra ones. But there are a few extra ones here. One is rotation, which we'll just leave at 0 because we don't want to rotate anyone. The other one is scale. So let's scale our sprite by 10 in the x direction and 10 in the y direction. And let's see what happens if we draw again. Great, our sprite got a lot bigger. The problem we have now is that it looks fuzzy, and this is because when you scale an image, the Love framework, or the graphics framework that we're using, will use different filters to scale the image, and the default filter it uses makes it fuzzy. It tries to make it look nice. Unfortunately, it doesn't look very nice with pixel art, but that's easily fixed. What we're going to do is, when we create our image down here, or when we load in our image, we are also going to call set filter, and we are going to say nearest and nearest. So we're changing, by default it uses a different filter. What we're doing is we're saying for this image, when we scale the image up and when we scale the image down, we just want to use the nearest pixel. We don't want to do anything too fancy. So if we run the code again, here we have our nice crisp pixel graphics. So the last thing we're going to do is let's go back and make our pixel move, because or make our sprite move, because our rectangle was moving, so why shouldn't our sprite? So what we have to do down here is, instead of x equals x plus 5, we now need to operate on our adventurer sprite. So if we say adventurer.x equals adventurer.x plus 1 or plus 5, then we should start moving, and down here we just need to say if adventurer.x is greater than love.graphics.getWidth, then adventurer.x equals 0. And finally, because we're always operating on our adventurer, we don't really need our x and y values anymore, so we are going to delete them, because we like deleting code. Because the code which you delete, or code which you never write, can never go wrong. So always go back and delete code you're not using anymore. It will just keep things much neater. It's just a quick sanity check and run the game. Excellent, something went wrong. I was hoping this would happen because it's always good to show people how to debug, how to fix problems. So what this is telling us is, on main.lua line 10, we are trying to perform arithmetic on field x, but x is nil because we just deleted x. So let's have a look at line 10, and we're saying adventurer.adventurer. So let's have a look at our sprite. XY, we return our instance, so we should have an x and a y value at this point. Let's take a quick look. Aha! Of course, we're not passing in our x and y values anymore, so now let's just set them to 0 and 0. So if you don't pass in an argument, it will be set to nil for you. So now, if we run the game, we'll see our adventurer slides across the screen. Great, so let's quickly recap what we've done in this episode, and then we will wrap it up for today. So what have we done? The first thing we did was we installed Love2D if we didn't have it installed already. We grabbed ourselves a nifty text editor, again if we didn't have one already. We made a new empty directory and we made a main.lua file inside it, which is all Love2D really needs to run and draw something on the screen. We created a couple of functions to interact with the framework and tell it what to do, and we created this sprite.lua module in order to assist us in drawing sprites and to keep our code nice and neat. Thank you very much for watching. If you have any questions, you can find me on Twitch. I live code sometimes on there, or just ask me in the comments, send me a message, whatever you prefer. If you'd like me to focus on anything in particular, if the current level is either too detailed or not detailed enough, do let me know. This series is all about teaching people, giving people the skills they need to make some fantastic games, so help me out by letting me know what you guys want to hear, and I'll do my best to help you. Thanks very much for watching, and good evening.